Our topic for today is TRIZ, 39 parameters and 40 inventive principles. TRIZ is actually TRIZ, TRIZ is the acronym from the Russian words. So we will look at after this, right? Before that, okay, this is actually our small team. Okay, our small team when we have any webinars about TRIZ, Dr. Rizwan, Dr. Zaid, and me will take normally we take 3 hours for all of the components in TRIZ. So Dr. Rizwan will take 1 hour, Dr. Zaid 1 hour, and me is 1 hour. So before this, we have also talk by PJM, which is conducted by Dr. Rizwan and also Dr. Zaid, also about TRIZ. So Dr. Rizwan normally share the knowledge about the engineering contradiction or function analysis. Okay, so Dr. Zaid will share about the trimming, and me myself will share about our TRIZ using 39 parameters and 40 inventive principles. Okay. So this is our group in UTEM. So we actually have 6 people in our team. And this is actually the training contents for TRIZ. So we have 1 day training, and actually for TRIZ certification of level 1 practitioner, we have 2 days training. So this is what I've explained, that Dr. Rizwan will share about the function analysis and cause and effect change analysis. Dr. Zaid will share about the trimming, and me the engineering contradiction using 39 parameters and 40 inventive principles. Right. So this is by Malaysian TRIZ Innovation and Association. So the slide is from my TRIZ, and this is a kind of our level 1. So we have actually in Malaysia, we have 3 level of certification of practitioner for TRIZ, and me myself is the practitioner of level 2 TRIZ and instructor for level 1. Okay, so this is the TRIZ acronym. TRIZ is from Russian word, which is Teoria Rashanika Izobreta Zadah. So this is a Russian word, and in the English is a theory of inventive problem solving, TIPS. So it is the same meanings of TRIZ in Russia. So in English, we call it a theory of inventive problem solving, but the acronym still TRIZ, TRIZ, because it is a very well-known acronym over the world. Okay, so I have mentioned that we have previous talk by Dr. Rizwan and also Dr. Zaid, and it is about the function analysis, cause and effect chain analysis, and also trimming. So the first one is the stage 1 that you need to know to define a problem root cause. Okay, and then you have trimming. Okay, this is a method of problem solving to actually generate a general solution to our problem. So the stage 2 is actually for the level 1 of TRIZ certification. We have the above stage 1 with the first of engineering contradiction, contradiction matrix, and also inventive 40 inventive principles. So this include the first level of TRIZ certification. Okay, there are if you can see from the figure, we have engineering contradiction, physical contradiction, function model, substance field model, and ARIS, algorithm of inventive problem solving. So this is the method in TRIZ according to the level. Okay, and this is the tools and application of TRIZ. The problem solving, define problem, and root cause identification. So we have to define problem and root cause identification. We have product analysis, process, cause and effect chain analysis, engineering contradiction, physical contradiction, substance. Okay, substance field analysis, failure anticipation, flow. So in here we have level 1 for cause and effect chain analysis with the engineering contradiction. Okay, to problem solving, solution generation, we have inventive principles. So we have 40 inventive principles that I will show you by the end of this talk. Function analysis, okay, failure anticipation, secondary, function-oriented search. Function-oriented search, I do it in my PhD, super effect analysis. And also we have also other tools like trends of engineering system evolution. So trends of engineering is, if we can remember that the simplest one is our ruler. Okay, so from ruler, plastic ruler, and then we have a flexible ruler, and then we have now the what we call the infrared. Okay, so we have the trend setting from solid, liquid, and we have magnetic. Okay, so trimming is also the tools that have been used in TRIZ. Okay, so before I explain the structured problem solving using TRIZ, so the structured problem solving is we have step by step. Okay, we have step by step, we have process, we know the advantage of TRIZ to complement structured problem solving process. So in there are basically general structured problem solving, and also we have our TRIZ problem solving. So we should have a look at it one by one. Okay, the structured problem solving is actually a step-by-step process. The first one is define our problem. What is the current situation? So this is the why questions. Before, if we have a problem and we need to define, we need to justify what causes the problem. So define problem, what is the current situation? So what is the cause of our problem? And we need to develop solutions. And then after we develop the solutions, we discuss and we implement the solutions and the standardized solutions, and repeat it again and again for the next steps of to solve the problem. Okay, so what we have in our define problem steps. So to define the problem step, we have to identify the problem and the importance of working on it. So to define, the output is establish a team and develop a problem statement. So there are key questions: nature of problem. What is the nature of problem? Is it about magnetic? Is it about electric, mechanical, civil? So there are other things. Is it about human? Is it about attitude? Just for info that the TRIZ is not only for the engineering problems. We have also TRIZ in business and management. So other from the engineering problems, we have also the human. Okay, actually in management, human management, business management, so that we can cater, we can solve our problem using TRIZ for the management. Okay, current situation. Current situation, the purpose is clarify the problem areas as the situation exists today. So this is the step that we need to know, and what is the purpose and output of every step. Okay, so this is the general or we call it as a standard problem solving procedure or structured problem solving, and then this is TRIZ. Okay, so from TRIZ we compare it with the structured problem solving. So we have we also have the structured of problem solving method. So from TRIZ, as in the flow of a figure, okay, that I showed you before, we have function analysis of product or process, and ideality. Okay, we have cause and effect chain analysis. This is for the current situation, problem, commonality analysis, scientific effect. So this is in TRIZ. Okay, so for now we will look at the 40 inventive principles. Before we look at the 40 inventive principles, we need to know the 39 parameters. Before we know the 39 parameters, we need to clarify our engineering contradiction first. Okay, so my sharing session today is about the engineering contradiction, 39 parameters, and also 40 inventive principles. Okay, so the basic concept of TRIZ is before we get to TRIZ, let's look at the basic concept of TRIZ. We have the basic concept of TRIZ, which is ideality, contradiction, resources, and system approach. So we look at the contradiction for today. Okay, what is contradiction? The contradiction is the opposition, the opposite, contra. Blue, sorry, the blue button is true, the red button is false. So the contradiction of the red and blue, and also the wording of blue and red in the red button and blue button. Okay, so contradiction, contra means opposite. Okay, opposing or opposite. Diction, point or speech. So contradiction is opposing point of anything. It is contradiction. You want to be fast, but you want fuel consumption. Let's say for a motorcycle, for a vehicle, for a car, you want to drive a car fast with the best fuel consumption. Okay, so it actually, if you drive so fast, and then you will not have the fuel consumption is the great fuel consumption. So the contrary is, if you go fast, the fuel consumption is higher. Okay, so another words of contradiction is like living dead, new classic, open secret, solid water, glass hammer, invisible ink, friendly fire. So that is a contradiction. Kalah menang, hidup mati. Okay, so there are contradiction. And we also have in engineering contradiction. So from TRIZ definition, the contradiction occurs when we are trying to improve one parameter, results in other parameters being affected negatively. Like I said, fast and the fuel consumption. Okay, so that is one examples of our contradiction. So so we are trying to look for contradiction. A key characteristic of an inventive problem, usual solution is trade-off. So you need to compromise. Okay, you need to compromise. You need to trade off. You get fast speed, but the fuel consumption is very bad. Okay, so you need to sacrifice the fuel consumption. If you want to save the fuel consumption, if you want to get the best fuel consumption, you need to drive slow. Okay, so you sacrifice the speed. Okay, so good and bad. Car travel faster is good, but petrol consumption is higher. Another thing, another example is kettle of water boils faster. So if you switch on your fire in a high volume, okay, so the water boils fast, but the usage of gas is higher. So it's a vice versa. So you need to compromise each other. If you need time, you compromise the usage of gas. The inventor must find and remove contradiction. So in TRIZ, we use the engineering contradiction with the contradiction matrix to get the 40 inventive principles. So there are steps that we need to use to overcome the compromise trade-off of our problem. So engineering contradiction is the deterioration. So this one, engineering contradiction is the deterioration of one of the important features of the system caused by improving of one another. You want a good improvement, the other one is bad worsening. Okay, so one improve, one worse. The product gets stronger, but the weight increase. The product gets stronger, but the weight increase. This is good and bad. Service is customized to each customer, which is very good, but the service delivery system gets complicated. So this is custom for each of our customer. Okay, so we are trying to overcome this engineering contradiction. So we have the engineering contradiction matrix. So this is one tool of engineering, of TRIZ, which is engineering contradiction. So from the engineering contradiction, you need to know the parameters that used in your problem. Okay, you need to know the parameters, and then what parameters is improved and what parameters is worse. So that is the contradiction, improvement and worsening. So you need to know which one is you are trying to improve. If you improve that one, what is worsening? So you need to know both. Okay, at least you have two parameters. At least you need to have two parameters to make sure that the engineering contradiction can perform using the contradiction matrix. Okay, so we will look at the system parameters, inventive principles, and finally the contradiction matrix. Okay, so this is the core of our session today. Okay, what is contradiction? So we know that contradiction is the opposite. Okay, we want something get better, the other one get worse. Okay, if I make the gas stove burn hotter, it's like the previous example, then the kettle of water boils faster, but gas consumption is higher. So the sentence for this one is we are using if, then, but. Okay, so if, then, but. This is the what we have, what we need to know, what we can define the parameters from this type of sentence. If I make the gas stove burn hotter, okay, then the kettle of water boils faster. Improve. but gas consumption is higher, worse. Okay. If I make the leaf larger, so if I make the leaf larger, what can it do? Then it can carry more loads. So there are more people can go into the lift. Instead of 5 people, we have 10 to 15 people in the lift. But what you sacrifice? It becomes heavier. Okay? So larger and then heavier. If I increase speed of the car, then I can reach destination in shorter time. But fuel consumption is higher. So we use if, then, but sentence for this one. Okay, traditionally the problem is addressed by compromise or sacrifice. So we call it trade-off. This is previous of function analysis. Actually, this is one of the stage one of the TRIZ method. The engineering contradiction is a situation in which an attempt to improve one parameter leads to worsen another parameter. So I have said it again and again. We need a contradiction, and the contradiction means that one get better, improve, one get bad, worse. So improve and worse. So the keyword here is improvement and worsening. Okay, so there are contradiction. What is improved and what is worse? The parameters. Okay, so you need to know what is the parameters that can be that if you change it, the parameters will improve. But what parameters that will be worse? Okay, so it can be reflected in a positive and negative interaction between two or more components. So this is the examples using the sentence of if, then, but. Okay, if, then, but. So you have here the improve factor, improve parameters, and then the worsening parameters. So from the sentence, if table legs are changed from plastic to metal, then the strength of the table improve. Okay, so the parameters is strength. The improvement parameters is strength, but the weight of table worse. Strength is the parameters, and weight is the parameters. So which one is improved and which one is worse? So it clearly defined here that the strength will be improved, but the weight will be worse. Okay, so the contradiction will be always improving parameters and worsening parameters. Okay, if table legs are changed from plastic to metal, then the strength of the table improves, but the weight of the table worsens. So you need to clarify the strength and weight. Manipulative variables is the diameter of the legs. Okay, so table legs. The contradiction is for improving parameter, you improve the strength, and the weight will be worsened. The contradiction, improving parameter, weight, and worsening parameter, strength. So vice versa. Okay. So I have explained about the improvement. Okay. So the improvement here, the improvement parameters and the worsening parameters. So for parameters, TRIZ have decided that there are 39 parameters that we have. Okay, there are 39 parameters that we have. We will look after it. So from the parameters, we need to clarify which is improved and which is worse. Okay. And then from the parameters, we have contradiction matrix. Okay. Okay. Now, this is actually a very useful to understand our session today. Okay. So we have 39 parameters. So this is 39 technical parameters. Okay. 39 technical parameters. And then we have contradiction matrix. So this is the matrix. The one with the numbers, the small numbers in here is this is the matrix. So this is what we call contradiction matrix. So the contradiction matrix have 39 technical parameters and also numbers. The numbers shown in the table in the matrix is the numbers of inventive principles. Okay, understand? Okay, so now from the contradiction matrix, we know that we have 39 parameters and the 39 parameters doesn't change. In TRIZ, it doesn't change. If the number one is weight of moving object, so it is weight of moving object. It cannot be changed to reliability. Let's say reliability is number 27. Because of what? Because we have create the contradiction matrix, and then the numbers is to show that this is the general solution for the 40 inventive principles. Again, we have 39 parameters, and then we have 40 inventive principles. The numbers inside this is the 40 inventive principles. So the numbers inside the matrix is only from 1 to 40. If you search inside here, there are no number 41 and above. So this is belongs to the inventive principles, 1 to 40. Okay, so this is what our session today is all about. Okay, so 39 parameters. Now we look at the improve. What parameters that we improve, and what parameters that worsening. So we have two parameters. I said that two parameters at least. You need to have two parameters at least. And then this is our technical parameters, 39. So for the left, okay, the on the left side, okay, is the improvement parameters. The parameters is the same. If you can see that, number one is weight of moving object. The table, okay, the header is also weight of moving object, number one. So the difference is the going down by row is improve parameters, and going to the right by column is worsening parameters. So total of it, we have 39 parameters, okay, from weight of moving object until the productivity. Okay, so this is the table. This is the contradiction matrix that we need to have. So we need to look at it. So as a general, so this is our session for 39 parameters for improving and worsening, and also 40 inventive principles. So what we need to do is we need to look at the parameters, improve and worse, and then the numbers of 40 inventive principles. Let's say this from the previous examples. Okay. Okay. So from the previous example, we improve the strength and we worsen the weight. Okay. So tables is not moving. So we have actually weight of moving object and weight of stationary object. So table is stationary. So weight is worsening. Weight is worsening. Number two, what we improve from that sentence? Strength. Okay. So we need to find strength. Strength. Okay. Number 14. So 14 versus number 2, which is 40, 26, 27, and 1. Okay. 140, 26, 27. This is the inventive principles, general solution that we need to know. Okay. So we know that inside the matrix, we have 1, 40, 26, 27. So number 1, segmentation. What is this about segmentation? Number 2, 26 and 27, copying. Number 3, sorry, 26 and 27 is copying. 27 is chip shot living objects. So apa ni? Okay, so just go through. Just go through. Number 1, number 26 and 27. Finally, number 40, composite materials. Oh, maybe change our table to composite materials so that our strength can be better and weight can be better. Okay, so it is not a compromise. It's not a trade-off. Okay, so that is the general solution. We have 4 general solutions: 1, 26, 27, and 40. Okay, now for the contradiction matrix, we have 39 parameters, 40 inventive principles, again and again. Okay, so the inventive principles are simple ways to resolve engineering contradiction. So the contradiction matrix that we have from the right left column and also the column above header for improve and worsening. So method 1, you can utilize the numbers. So the numbers from the examples is 1, 26, 27, and 40. Okay, you can utilize that one. Or number 2, if you are familiarized with all 40 inventive principles and apply each or combination to solve engineering contradiction, you can always look at all of the 40 inventive principles one by one, and then you can have some ideas. Okay, so from that one, we have the contradiction matrix, and then 40 inventive principles. Okay, so they are included in only one page. Okay, one page. We have 39 parameters, and this is all the contradiction matrix, what we call contradiction matrix, and we have the 40 inventive principles. So the only thing that we need to know better is the 40 inventive principles. You have known that the parameters, okay, the parameters, there are 39 parameters, and we need to look at the 40 inventive principles. But before that, I will show that the 39 parameters. Okay, this is the same thing that I've shown you with the improvement of strength and worsening of weight previously. Okay, so this is the parameter. How do you know? Okay, how do you know the parameter? Is it about strength? Is it about speed? Is it about productivity? So that is the parameters. So where are you from? Where are you from? Dia tanya kan. Yes, I'm from Egypt. How did you guess? So how do you know that is the snail is from Egypt? Okay, so zebra crossing, Minangkabau. Okay, so something guess of the parameters from what? This is our 39 parameters that listed in our contradiction matrix. We have weight of moving object, stationary. Okay, so we look at the weight, length, area, volume, speed, force, so forth and so on, until we have energy, substance, information, time. Okay, so this is some kind like our fast car. If we drive fast, so what we get and what we worse, what the bad factor. Okay, so this is the 39 parameters from TRIZ. We have also business and management, and I show you the parameters in business and management. So the business and management use, okay, before this, we have weight, area, volume, length, right? So in business and management, we have degree of responsibility, coverage, number. So that is different between engineering and business and management parameters. So this is the comparison that I put it from 1 to 20. So number 1 and 2 is weight versus degree of responsibility. Length versus coverage or span of employee responsibility. Okay, so that is the different between engineering and also business and management. Okay, inventive principles. We have inventive principles that is actually screen Altshuller, generic Altshuller, which is the TRIZ master. Okay, he is the founder of TRIZ. Okay, generic Altshuller screened 200 patents. So submission of patents in Russia go through him. So he screened the 200,000 in order to find out what kind of contradiction that resolved by the peoples. Okay, so after they synthesize, he knock it down into 40,000 innovative patents. So 40,000 innovative patents that he said that it is completely again and again and again the same thing with this different, the same method to the different things. Okay, so there comes our 40 inventive principles. So let's review the 40 inventive principles. But for me, now, for our session, I can only show 10 of the inventive principles. Okay, but I can give the explanation or the slide also for others, for the participants to look at the other 30 inventive principles. So that inventive principles is very simple, in a simple explanation, so that we call it a general solution for us. Okay, so we have segmentation, taking out local quality. This is the inventive principles, and I know that you are asking that, what do you mean by segmentation? What do you mean by taking out? What do you mean by local quality, so forth and so on? Okay, until the composite materials. Okay, so the explanation is we need to know it one by one. After, let's say we have an examples. Okay, we improve the temperature, number 17, and then the worsening factor is length of moving object. We improve the temperature, so number 17 versus number 3. So the contradiction matrix is 15, 19, and 9. So let's say it is like that, 15, 19, 9. So try to look at the number 15. Dynamization. What is dynamization? Number 19, periodic action. Okay, something that I can ponder, periodic action. And number 9, preliminary anti-action. So something, the keyword something action about it. So this is the only general solution. The specific solution is up to the engineers. Okay, up to you. Okay, the first one is you need to understand what is preliminary anti-action explained for. Okay, so this is the 40 inventive principle. This list is the same as this list on the right side. Okay, it is the same. 40 numbers, segmentation until 40 composite materials. Okay, so it is the same. Okay, so I just explained at least 5 maybe, and then we go to some examples. Principle number 1. So after you get your contradiction parameters, and then what is improved, what is the worsening parameters. Okay, then the answer shows you inventive principle number 1, which is segmentation. So segmentation, what is mean by segmentation? Divide an object into independent parts. Okay, so independent parts, something like IKEA tables, IKEA chairs. Make an object easy to disassemble, or number A and B, your mind is going to like IKEA. Okay. Increase the degree of fragmentation or segmentation. If it is have been segmented, you need to increase the segmentation, or you need to transition to micro level. So segmentation. So the explanation is number 1, a concept of modular furniture where the components of the furniture are disassembled at the point of purchase and during transport. Okay, dah tahu dah kan, IKEA. Segment large files into small data packets. Okay, this is for the IT. So we can also engineering, IT engineering. Okay, that is the examples. Number 2, taking up. Taking up. Okay, the inventive principles is taking out. So what it is all about? To separate an interfering part of property from an object. So take out. Single out the only necessary part of an object. So the example is move a person to an area where the person's strength can be fully utilized. So get used to take out that person because he is so good to go to the next level. Okay, identify the extreme behaviors in the group. Just-in-time inventory management. So this is the explanation. The air conditioning compressor, which is noisy and hot, is moved to outside of building. Okay, so taking out. So it is hot and noisy. Taking it out. So the compressor is at the outside and the blower is inside our house. Local quality. Local quality is you have it is something like a department. Okay, that you separate in department. Change an object structure from uniform to non-uniform. Change an external environment from uniform to non-uniform. So as an example, vacuum cleaner, which has a part suck up the dust, another part is a filter, and another part is store. Okay, so the other part is for the storage of the wire. Okay, so local quality. Create recreational rooms. So pantry area, skill personality matching in project teams, flexi work hours, kids area. So local quality. So which one is the quality? We have finance, we have management, we have engineering department, QA, QC. So local quality. Asymmetry. Asymmetry. So this is nice. Change the shape of an object from symmetrical to asymmetrical. If it is symmetry, change it to not symmetry. Okay. If an object is already not asymmetrical, increase to symmetry one. Okay. Vice versa. Okay. Assemble a team with good competencies depending on problem to solve. Create diverse team consisting of men, women, young, old, conservative, aggressive. So this is asymmetry. Number 5, merging. So you merge whatever problem you have. If you have the inventive principles, number 5, you need to think about merging. Bring close together or bring close together identical or similar objects. Assemble identical or similar parts to perform parallel operations. So this is merging, combine team members. Okay, something like that for management. Last, universality. Universality, multifunctionality. Make a part of object perform multiple functions. Eliminate the need for other parts. So this is kind of inventive principles number 6. So we have 40 inventive principles. So I don't want to explain each and every single inventive principles, but I want you to know that for the inventive principles, before we go to the 40 inventive principles, we have to know the engineering contradiction. Okay, what is engineering contradiction? It is about parameters. Okay, different parameters. What is improved and what is worsened. After we know the parameters that improve and worse, we have the contradiction matrix to find our inventive principles. Okay, so that is why our session today we name it 39 parameters, 40 inventive principles. Okay, but there are steps that you need to know before you go to the parameters, which is engineering contradiction, and then in the middle, you need to know the contradiction matrix before you go to the 40 inventive principles for general solution. And final step is you need to create your specific solutions. As an examples, okay, this is exercise. Okay, this is our case study. If the cable is long, so we use the engineering contradiction using the sentence of if, then, but. If, then, but. So if cable is long, then it can be used to connect and charge electronic for over longer range, but cause problem of dangling and unorganized. So we can have as many as the engineering contradiction. So from this one, from the problem statement of sentence if, then, but, okay, so we have made we have defined our parameters, and also we have defined our inventive principles. Okay, so improving parameter in the contradiction, long cable when in use, worsening parameter. So the improve and worse parameter is length of stationary object. This is the parameter which is improved. Worsening parameter is the versatility. So dangling, it is unorganized. So from the contradiction matrix, 4 versus 35. Okay, let's look at the improve number 4. Number 4 to 25. 25 is no 35. Sorry, number 4 to 35. Okay, so the inventive principle is number 1 and number 35. So number 1 segmentation. Oh, this ni lain ni. Number 35 parameter change. So what can you do with the parameter change and segmentation? So you need to think. Okay. After that, if you don't have any idea, you can go through the other 40 inventive principles. So you can use the 40 inventive principles even the numbers is not in the numbers, the inventive principles is not in the contradiction matrix. Still you can. So this is our design of the problem of our dangling wire. Okay, so from that, I will show. There are also inventive principles that have been explained in internet. You can find it in the internet if you want to know about the segmentation, local quality, preliminary anti-action, and this one I downloaded from websites. Okay, so it explains about the segmentation. So number one, inventive principle, segmentation. So divide an object into independent parts, make an object sectional, easy to assemble or disassemble. So this is the explanation. Okay, this is the explanation of the inventive principle number one until number 40, which is composite materials. Okay, composite materials change from uniform to multiple materials. Aircraft, composite, concrete, glass, something like that. Okay, so you can find it a lot if you want to understand, because me myself also need to find, let's say number 38, accelerated oxidation. I don't know what it is, so I need to find it from Google or others explanation in the book, so that I can make sure that the general solution can be understand. I can I can give the specific solutions to the problems that I have faced. Okay, that I have faced. Okay, so the conclusion for today is that we have 39 parameters and 40 inventive principles. So again and again, you have to know the engineering contradiction, which is improved and which is worse, before you know the 39 parameters. And then from the 39 parameters, you need to find the improved and worse from the column and row. And then you need to find the 40 inventive principles. After you have find the 40 inventive principles, you can you can get the general solutions, and then you make your own specific solutions. Okay, I think that is all from me for today's session. So I hope that you can understand that there are methods from TRIZ, from engineering contradiction. Normally we have engineering problems. So the engineering contradiction, 39 parameters, contradiction matrix, 40 inventive principles. Okay, so that's all from me. If you have a question after this, thank you, Dr. Nizam.